Hi, this is Marwan, and today we're going to start a new group of videos about complex numbers. Our first video is going to be an introduction to complex numbers. Then we're going to be discussing adding and subtracting complex numbers, then multiplication of complex numbers, dividing complex numbers, and our last video in the series will be complex numbers SAT questions. We will try to keep them short so you can listen to only what you need. Okay, what are complex numbers? Now, the complex numbers are numbers that include an imaginary part. What do we mean by imaginary part? Now, if we have to find the square root of a negative number, it's actually going to be confusing. Let's try a number like -4. Can we find the square root of -4? Do we have a real number that we can multiply by itself and get -4? Well, let's try. If I multiply +2 by 2, a number by itself, you're going to get 4. If you multiply -2 by -2, a number by itself, you're still going to get a +4. So in both cases, you're never going to get a -4. So the square root of -4 does not equal neither 2 or -2. So what is it equal to? This is why we have the imaginary unit. The imaginary unit I is the complex number whose square is -1. What does that mean? It means that I is equal to the square root of -1. So I squared is equal to -1. So I multiplied by I, which is I squared, is equal to -1, which makes the square root of -1 is equal to I. How is this useful? Now here, if we have a rule, the rule will state that for any positive number a, the square root of -a is equal to the square root of -1 multiplied by a. Square root of -1 is I, and the square root of a stays as square root of a. Let's apply. If we have square root of -5, this is how we're going to simplify it. We're going to say that the square root of -5 is equal to the square root of -1 multiplied by 5. Which is the square root of -1 multiplied by the square root of 5. Now, we said before that the square root of -1 is the imaginary unit I. So this is going to be equal to I radical 5. Now, one important thing, a trick that we have to take care of, is that the square root of -5 squared is equal to -5. How? Well, because it's equal to I radical 5 squared. When you distribute the square, you will get I squared, which is -1, multiplied by radical 5 squared, which is 5. And your answer is going to be -5 and not 5. So now that we understand where the imaginary unit I comes from, it is the square root of -1. So if I have any negative number under the radical, I'm going to break it into -1 multiplied by something. Let's look at what we have here. How do we write each number? By using the imaginary unit I. Well, let's try. This is square root of -12. So this is -1 multiplied by 12, which is the square root of -1 multiplied by the square root of 12. Square root of -1 is I. What about square root of 12? Well, this is equal to 4 multiplied by 3. The square root of 4 is equal to 2, and the square root of 3 is radical 3. Now, is this the simplified form? No, we write it as 2I radical 3. Now, what about square root of -25? Again, square root of -25 is -1 multiplied by 25. Square root of -1. By time, you will get to do this in one step. Square root of -1 is I, square root of 25 is 5, so this is actually 5I. What about square root of -7? Again, square root of -1 multiplied by 7. Radical -1 multiplied by radical 7. Radical -1 is I, and radical 7 is radical 7. It's just in the way we write it. If I have a whole number, we put it before the I. If we have radical, we put it after the I. Square root of -12 is 2I radical 3. Square root of -25 is 5I. Square root of 7 is I radical 7. Now, what else do we need to know in general about complex numbers? We need to know that a complex number has two parts. One real part, which is the one that does not have I, is it? Like when we have 5 plus 3i, 5 here is the real part. And 3 is the imaginary part because it's combined with I. Now, we know that we have real numbers, like a number like 2. This is actually has only a real part. Its imaginary part is 0i. We have pure imaginary numbers. Imaginary numbers are like 2i only, and it has a 0 for the real part. And we have imaginary numbers which have both. It has a real part and an imaginary part. Now, what does this diagram represent? It represents that the pure imaginary numbers is a subset of imaginary numbers, which means that imaginary numbers include also pure imaginary numbers. Both imaginary numbers and real numbers together make the set of complex numbers. So this is why when you are solving a polynomial equation, we would say that find all complex roots. What do we mean by complex roots? We mean both real roots and imaginary roots. So complex numbers stand for both. It stands for real numbers and imaginary numbers, which include pure imaginary numbers. Now, how do we graph those imaginary numbers? Now, complex numbers cannot be graphed on the coordinate plane. Why? Because there is an imaginary part to it. So actually, the x-axis, which we used to have in the coordinate plane, is here what we call the real axis. And the y-axis is what we call the imaginary axis. Both of these axes together make what we call the complex plane. If we have a number like 3 minus 2i, how do we graph it? 3 is the real part, so we will move 3 units to the right because it's positive. And 2i is the imaginary part, so we're going to move 2i down because it is negative. Now, this point here is the point 3 minus 2i. So now we know how to graph it. One thing else we can know is how to find the distance between that number and the origin. We find it by finding the absolute value of the complex number. So the absolute value of 3 minus 2i is the distance between 3 minus 2i and the origin. And we actually use the distance formula to do that. So if I want to find the absolute value of 3 minus 2i, it is equal to radical 13. But how do we find that? You're going to do the 3 squared plus the negative 2 squared. Remember, it's a distance. So you are taking the distance between the point and the origin. So we don't need to include the I. So this here is equal to square root of 9 plus 4, which is radical 13. Now let's do some examples. What are the graph and absolute value of each number? Negative 5 plus 3i. Now, if this is the complex plane, now here we're going to have the real part, and here on the y-axis, we're going to have the imaginary part. Okay, so I have negative 5 as the real part, so I'm going to be moving left 5 units. So that's 1, 2, 3, 4, 5. So here we did represent the real part. Then the imaginary part is 3i, so we're going to be moving up 3 units. 1, 2, 3, and this is my number. This here is negative 5 plus 3i. If I want to find its absolute value, it means I want to find the distance between this number and the origin. So the absolute value of negative 5 plus 3i is equal to the square root of 5 squared, negative 5 squared, sorry, plus 3 squared, which is the square root of 25 plus 9, which is radical 34. Now, what about 6i? How do we graph 6i? Let's use a different color. Well, 6i is only a pure imaginary number. It does not have a real part to it. So we're going to be moving on the imaginary axis. How many units? 6 units. That's going to be up. 1, 2, 3, 4, 5, 6. So this here is 6i. And it's obvious that the distance between it and the origin is 6 units. But how do we write it? Again, absolute value of 6i is going to be the square root of, there is no real part, so this is 0 squared, plus 6 squared, which is the square root of 36, which is 6. That's if you want to apply the rule. So now it's going to be time for you to practice. You're going to be writing your answers in the comments box, and I'll let you know if it's correct or not. Our next video is going to be about adding and subtracting complex numbers. I hope this has been helpful for you, and thank you so much for watching.